Hi, good. Okay, apparently you can. Okay, I'm planning on going over the some of the methodology you might be able to use in the project. So, like any those of the students that are still struggling a little bit can really kind of get a jump start from this. Okay, so I should be recording now. Okay, so to look at the our data sources for the project. Okay, so those of you, there are a couple of groups that might be online now. Some from our strictly online section, and we have some students that are doing a brick and mortar course also. So I don't know how many of those would likely to be on now, but they might benefit from this recording too. So at this point, both groups have at their disposal two different sets of databases. Actually, it's a single database, but one of them is a derivative of the other. For instance, we have the Community Health Survey from 2013. Okay, we have the full set of data, and we also have a simplified set of data from that same Community Health Survey. So I'm going to open one up right now. I'm going to start by opening the full data set, the big data set. Okay, let me navigate to our desktop here and to the review folder. And here we go. Where is it? There. Nope, I got the wrong one. Let me see where I put this. There we go. It's in here. And here's the full data set. I'm going to double click on that and open it in SPSS. Okay, so here's our data set. Now we can view in SPSS, you'll notice that we have menus at the top here, drop menus at the top, file, edit, view, data, transform, analyze, which is important to us, direct marketing, graphs, which is important to us, and so on and so forth, and windows, which allows us to move between the output window and the input window. Now, in the input window, we have two different views. We have the data view, which actually lists all the columns of the variables, and the variable view, which allows us to see how these different variables are structured. So, for instance, we have in this particular database, the full database, we have 209 variables in here. Some of them are scalar variables. A few of them are scalar variables. Not a whole lot of them. For instance, I'll take a closer look at them in a little bit. But a lot of them are also nominal variables. In other words, categories: yes, no, took a flu shot, has diabetes, yes or no, so on and so forth. Okay, so we're going to take a look at how that impacts what we're going to be doing as we work on our projects. Okay, so I'm going to leave the chat box somewhat open, so if there's a question, I'm hoping that I can see it pretty quickly. Okay, so now there's two ways to go back and forth between the data view, where we actually see each column represents a variable, mood 1, the variable mood 1, the variable mood 2, the variable mood 3, and the variable view, where the variables are represented. Each column that was in the data view is now represented by a row. Mode 1, mood 2, mood 3, and so on and so forth. And the variable view allows us to inspect this and see what kind of data we're dealing with. For instance, mood 1, the question that was asked in mood 1 was, in the past 30 days, how often that you feel so sad that nothing could cheer you up? A measure of depression, for instance. Okay, so that particular variable, might be a numerical variable or it might be a categorical variable. We have to find out which it is. Okay, and the way that we find out what that variable is, or let me find another one. Let's see over here, demog or demographics, it's short for demographics, demog1, what is your age? Well, that's clearly likely to be a numerical variable, but we're going to check that as well. Okay, so, and SPSS is going to make a determination, or at least as best guess it can, on whether that's a scalar variable or a nominal variable. For the age, it's guessing it's that a scalar variable. It's doing that by looking at the data. Okay, in the case of mood one, it's guessing it's a nominal variable. Now, if they're saying exactly how many days out of 30, like 4 days out of 30, 7 days out of 30, 22 days out of 30, that would probably be more likely a scalar variable. But it may be instead that this data is stored in such a way that it's a categorical variable. In other words, not at all, 1 to 5 days, it might be something like that, where there's categories of days. So it's not really a scalar or numerical variable. But we need to determine that. We're going to see how to determine that right now. So right now I'm going to leave it on nominal, which was the guess. One way we can determine it is go back to the data view and just look at it. So mood one, all of the numbers appear to be between 1 and 5. So none of them are zeros. So I'm thinking that those are categories. That 1 through 5 represents a category. And Demog 1, 64, 28, all numbers that are greater than 18, which is the minimum age for the survey. So I'm thinking that's the actual age of the individual subject. Subject 1, subject 4, subject 8, and so on and so forth. So we have a numerical variable and we have a categorical variable. I'm also interested in, let's see, look at this one. This one's interesting. This is all 1s and 2s, mood 9. Let's take a look at that one. Mood 9, the question was, mood 9, where'd it go? Here it is. In the past 12 months, have you taken a prescription medication for a mental health problem? Well, that sounds like a yes or no question, but we're going to check mood 9 also and see if that's indeed the way that it works. Okay, so don't worry about being a little late, because you can drop into these things and leave anytime you want to unannounced. You don't have to let me know. And hopefully this will properly record. We have it recording right now. I'll check. Yes, we do. So I'll be able to upload it tonight so that anybody that's not here will be able to look at it too, or you can back up. So we're going to take a look at those 3 variables. Okay, so the way that I'm going to determine what those 3 variables, how those 3 variables are structured, I'm going to get that output window out of the way, is I'm going to go to the code book for this data. I'm going to double click that. It's a PDF file. In the code book, we have a description of what each variable represents. Okay, and it's interesting in the code book, in the questionnaire, the variables. There's another data file called the questionnaire, where they actually describe how the study is set up, how the questions are asked, so on and so forth. And they go in the sequence that the questions are ordered, like mood 1, mood 2, and so on and so forth. These are sorted into groups that describe different categories of data. For instance, these variables are all access to health insurance, and so on and so forth. There we go. The next group of variables are cardiovascular health. Next group is diabetes. Next group is asthma, and so on and so forth. So some stuff that we're pretty interested in. So for instance, where asthma is concerned, one of the questions is one of the data variables is ever asthma. And the question was, have you ever been told by a doctor or a health professional that you have asthma? And the raw variable name is asthma 1, or it might be also ever asthma. It might be under either one of them. And the answers, 1 represents yes, 2 represents no. Everything else is basically just the missing value. So this is an particularly interesting variable, because we know this when we have a categorical variable with only 2 values, yes and no, we're going to have the opportunity to do chi-square and odds ratio and relative risk along with the chi-square. So that's a particular interest. Now let's see if we can't find the variables that we were interested in. One of them was mood 9. I'm going to do a search for it. Actually, I'm going to do mood 1 first. Okay, let's see if we can find it. Okay, here we go. Here's mood 15. Let me see, maybe it's in here. Mood 11. Here's mood 1. Okay, mood 1 is a categorical variable and has several categories. It is all of the time, most of the time, some of the time, a little of the time, or none of the time at all. Okay, so we have 5 categories there. So it's a categorical variable. Depending on what we want to examine about mood, if we examine a numerical variable like age related to a person's mood, then we might be using analysis of variance, right? Because that's what we use for a numerical variable when you want to compare means of different groups. The mean of the people, the mean age of people who said that they're depressed all of the time, mean age of people that are depressed some of the time, and so on and so forth. So we're going to take a look at that, but now we know how to code this. I'm going to do a real quick screen capture there so I don't have to go back there. Oops. I'm going to save mood 1. Okay, the next one I'm going to look for is ever asthma. Let's see if that, there's ever asthma. Okay, and that turns out indeed to be a yes or a no. Okay, yes, you've been told you have asthma, or no, you don't have asthma. So I'm going to grab that one also. Okay, and the next one was, I think it was Demog 1, which was age. Okay, and I'm doing this this way. Oops, this is gonna be a little bit harder to find because there's so many Demog that start with the digit 1. Here we go, Demog 1. Okay, age group. I actually saw, let's see, age group, Demog 1. Actually did see the numbers there, so one of these is going to be numerical. Demog 1, Demog 19. Let's see where it is. Oh, age group. Well, these are ages, so I bet you it's in here somewhere. What is your age? We only ask this question to make sure we have talked to enough people in each age group. Age group. What is your age? See of. I don't see it in here. Let me take a quick look back here. Let's go back to my PDF file, which seems to have disappeared. Let me reopen it. Okay, let me close the window. Oh, it was there. And reopen it. Okay, here we go. Okay, actually I wanted to go by data file. And where did I see Demog 1? Numeric. It's in, let's see, what is your age? Question 7.1, what is your age? See if I can't find it back here. What is your age? We want to make sure. Frequencies unweighted. Demog 1. Well, I know it is a numerical variable. I could tell by looking at the data. They don't make it really clear here. Age group, Demog 1, and question 7.1 and 7a. Okay. And that was question 7.1. What is your age? Let's see what that data looks like again. Demog 1. Well, those are definitely not categories. That's definitely numeric data. So I'm going to ignore what it has in the code book, and I'm just going to stick with that. Okay, I want to look for one more variable. Let's see. Let me just run through this. See, there's 209 different variables. I already have one that is a category. I have a numerical variable, which is age. I have a categorical variable with only two values, which is whether a person has asthma or not. And I have a categorical variable that has several values, not just two, like yes or no for asthma. Instead, it has several, like depressed all the time, and depressed most of the time, and depressed some of the time, and so on and so forth. And with numbers representing these different categories. And I just want one more variable that has only two values. And let me see what area this I might be interested in. How about, let's see, how about physical activity? Okay, and that physical activity is going to be down around 16. So I'm going to go search over there. So you guys may have this experience as you're going through this, looking for something that you're interested in terms of evaluating. You may have the experience of going through here and looking at all these different variables. Okay, how about this one? This is a nutrition one. Consumes one or more sugar-sweetened beverages on an average day. And an average day. One is yes, and two is no. I'm kind of surprised because I thought the Coke is selling a lot of Coca-Cola, but it doesn't look like many people want to admit to drinking it. Okay, so that one is SSB, is the variable, and the question is, do you consume one or more sugary drinks? Okay, so I'm going to grab that one also. Okay, I'm going to take a look at your questions there in just a second as soon as I save this. Okay, let me check. Yeah, I think that's all I have for age also. I agree with you. Yeah, actually, tell you the truth, Mavis, that it appears that they have several variables for demographics, including age, and in this case, it looks like that particular one, Demog one, is not coded into categories. It's the actual ages of the people, so it's a numerical variable, even though it doesn't make it that clear in the code book for some reason. That particular variable happens to be a numerical variable. We can see that because we can actually see the ages there. Okay, so let's see what we have now. Let's go and see what we have now. We have, I'm going to close the code book now. We have four variables that we're interested in. One of them is whether a person has asthma or not. Another one, I'm going to pick just two variables right now. Another one is how much sugary drinks that they drink. Okay, so I'm thinking maybe I want to know something about people with asthma, how careful they are with their nutrition. Okay, so let's say I'm interested in knowing whether or not there's an association with having asthma and drinking a lot of sugary drinks. Okay, so I know that there's two variables in here that are relevant to this. One variable is called ever asthma. The other variable is called SSB or sugary drinks. Okay, so now what I'm going to do is I want to find those variables easily. So they're not in the same order as the code book is. So I would have to spend a lot of time scrolling through here. Notice BMI. That's we have BMI in here also, another numerical variable. Okay, I have to spend a lot of time scrolling through here to find these variable names. So what I'm going to do is I'm going to control click on the Mac or right click on the PC on name in the variable view. And I'm going to say sort that for me ascending. So now it's asking me, do you want to save the current pre-sorted variable order in a new attribute? I don't care about that. We're just going to leave it sorted. So I'm going to say, no, I don't want to save it. So now it's sorted alphabetically. So if I want to find asthma, okay, if I want to find asthma, asthma is going to be, let me click away here so I can read it a little bit easier. Let's So if I can't find it, let me see what I'm trying to remember exactly what the variable name looked like. Whoops. Okay. Ever asthma is the name of the variable name. I want to find ever asthma. And where is it? Ever asthma. Here is that variable. It's the 70th variable across. Okay, so now I'm going to work with that variable, and I'm going to work with the variable a sugar SSB, I think it was, right? SSB consumes one or more sugary drinks. We know that those are both categorical variables. Both of them are answered yes or no. Okay, so I'm going to work with that. What kind of test do we use when we want to see if there's an association with two categorical variables, especially two that have only two values each? Each of them is, for instance, a yes or a no. Which test do you think we'd be working with there? Chi-square, perfect, right? And not only that, because it's going to create a 2 by 2 table, I can also do what tests with it besides chi-square? That'll only work with a 2 by 2 table. I can do odds ratio and relative risk, as a matter of fact, but odds ratio is the main one that most of these studies used. Okay, so now let's go ahead and do this analysis. I'm going to say analyze, and in order to compare, to create a crosstabs table and to see if there's an association, I would go into descriptive statistics and crosstabs for chi-square. I'm going to click on that. It's going to come up. So now we're faced with finding these variables again. And I want to move the variable that represents the exposure into the rows and the variable that represents the outcome into the columns. So I'm going to look, for instance, to see if people who have asthma tend to drink more soda. So I'm going to put the asthma in the rows and the sugary drinks in the columns. You might make the way you might reason it might work the other way around, but that's the way I'm thinking of doing it. So ever asthma goes into the columns for me. So now I got to find it. Okay, so now this gets a little bit more. This gets a little tricky now because it's displaying the questions. If I hover over these values, it then displays at the very end there. You can see the variable name. See Demog 17 at the end there. So this is a little tricky trying to find this stuff this way. I'm going to show you a trick to get around that in a bit, so that we don't have to scroll through all of this data every time we're searching for the stuff that's relevant to us. But for instance, ever asthma, let's see where that might be. Have you ever been told how many hours have see if I can't find it easily. Ever told by a doctor and nurse you have high blood pressure, total cholesterol, depression? Okay, let's see if I can't find it. Okay, I'm gonna do what I was planning on doing before. Okay, I'm actually gonna show you one of the ways that you might deal with having these things scattered around so much. Actually, I could tell it was 173rds. That would be pretty close to the end on this one. And ever asthma Oh, no, actually, it's not even going to tell. It's not going to be able to do that because it didn't alphabetize it in that option. Okay, so I'm gonna instead I'm gonna take the variables that I'm most interested in, and I can actually move. There's two ways I can handle this. I can actually take that variable and move it to another location. This is a little tedious, right? But what I could do instead is, let me go back down here. That's one thing I could do is move it. The other thing I could do is just eliminate all the variables that I don't need. Okay, so for instance, I know I don't need any of these variables here all the way down to, let's see, I'm going to leave BMI in because I might be interested in evaluating that later. I'm going to highlight them and I'm going to say clear. I'm going to create my own new data set. I'm going to leave Burrow in there also, just for the hell of it. Okay, let's see. Current asthma. I'm going to leave Demog1 in there. I know I'm going to need that. Clear. So all these others that I don't need. So now at the top I have BMI, I have demographics, I have Burrow. I hope did I eliminate something there? I don't think so. Okay, so now I'm going to keep Demog1 in there. And I'm going to leave diabetes in there too. I'm going to clear this. Okay, let's see. Ever asthma. There's our ever asthma variable. So I'm going to clear what I have so far. Okay, let's see what other variables I was looking at. Insurance. Mood 1. Clear that. So now I have my variables there. And let's see, I have my Demog 1, I have my Ever Asthma, I have my Mood 1. Now I'm looking for my sodary drinks. SSB, I think it was. There it is. So I'm going to eliminate all those others in between. Clear. And I think, and now let's go to the top again, and I'm going to get rid of all these others. Okay, so the next thing I'm going to do is I'm going to say save as, and I'm going to save this data set under a new name. Instead of CHS 2030-10, CHS 2013, I'm going to call it CHS 2013 Reduced Data Set 1. This is our new reduced data set, and I'm going to save this. By doing that, I now have preserved the original data set. I haven't affected the original data set. See, it's still there. We have that one, and we have the original data set, full data set here as well. But now it's going to be a lot easier for us to work with. So let's try our analysis now. Analyze, descriptive statistics, crosstabs. I'm going to move, have you ever been told by a doctor that you have asthma? I'm going to move that into the rows, and I'm going to put in consumes one or more sugary drinks into the columns. Okay, so first thing I'm going to do is I'm going to go into our cells, and I'm going to say, well, let's start off just simply by doing the observed values for our crosstabs. So I'm going to click OK, and sure enough, here's our crosstabs table. If we can't get up there and bring it up here a little bit, here's our crosstabs table. So among people that consume one or more sugary drinks, 288 of them have been told they have asthma by a doctor. Well, I'm not sure, right? Because I don't know what one represents here, do I? Oh, you know why? Because we haven't coded that variable yet. So I have to go back here again because it's displaying 1 and 2. The answers are in the survey, but it's not telling us what 1 and 2 represent. That has to go in for any of these variables that are categorical variables. That number has to go into the values here so we know what it is. Okay, so for instance, ever asthma. What represents a 1 and what represents a 2? Let's take a look at our code book again. Okay, so where'd our code book go? Let's see, desktop and eek. Okay, code book. Here's our code book. Okay, so I'm going to go to ever asthma again. Actually, I don't even have to do that, do I? Didn't I save those to the desktop? I think I did. Yeah, ever asthma. Let's see what that said. It said that 1 equals yes and 2 equals no. Good, now I can code that. Let me get back to my SPSS file. Okay, so for ever asthma, I can go into values. I'm going to say 1 equals yes. And 2 equals no. Add, make sure you say add before you say okay. And for sugary drinks, we might as well take care of that now too. Sugary drinks, let's see, 1 equals yes, they consume 1 or more sugary drinks. 2 equals no. Let's go back to our table here, to our data. Okay, and sugary drinks, 1 equals yes, and 2 equals no. Oops, 2 equals no sugary. Okay, I'm going to modify 1 just a little bit. Okay, it's going to make our table a lot more intelligible. I'm going to click OK when I'm done. Okay, so let's look at that table again. Analyze, descriptive statistics, crosstabs, and I'm going to repeat this analysis and see what I wind up with. Well, this time it's more obvious. Yes, consumes sugary drinks. No sugary drinks. Has asthma. How many people have asthma and consume sugary drinks? Out of 8,288. How many have asthma and don't consume sugary drinks? 808. And among people that don't have asthma, it's 1,600 versus 5,800. Well, let's see if people who consume sugary drinks have some association with having asthma. Okay, now let's see how we're going to do this. We're going to go up to Analyze, Compare Means, Analyze Descriptive Statistics, Crosstabs. And this time I'm going to go into Statistics. Actually, I'm going to do 2 things. I'm going to go into Cells and tell it to give me the percentage by rows also, so I can see the rates at which they consume sugary drinks. And I'm going to go into statistics. It asks it to perform a chi-square and a risk evaluation. That's what's going to give us our odds ratio when I get a risk ratio and our odds ratio when I check off risk there. Okay, and I'm going to click OK. We'll see all these extra analysis being done now. So here's our table. And our table says that people who said yes, they have asthma, 28.6% of those people consume sugary drinks. Among people who don't have asthma, only 21% consume sugary drinks. Well, that's interesting, isn't it? It seems like people who have asthma are more likely to consume sugary drinks. Kind of a little bit of a surprise, right? Okay, so now, now, how do I know that finding, that difference is not due to chance, that it's such a big difference that it's statistically significant, at least to the point where we have less than 5% chance of being wrong if we reject the idea that there's no association here? Well, we need to set up a a null and alternative hypothesis. And our null hypothesis might be that there is an association, there is no association between asthma and consuming sugary drinks. That's our null hypothesis, that there's no association. An alternative hypothesis is that there is an association, that whether you have asthma or not affects whether or not you're more likely to drink sugary drinks. Okay, so now we have our null hypothesis in our heads. Let's go ahead and do the calculations. Okay, well, chi-square for this 2 by 2 table turns out to be 13.18, and our significance is way below 0.05. It's not really 0.000. It's really that it's less than 0.001. So SPSS just displays it as the first three digits, 0.000. It might actually be a 9 as the next digit, or an 8 or something like that. Okay, so this tells us we can reject the null hypothesis that there's no association and accept the alternative that there is a difference in the rate at which people with asthma consume sugary drinks versus people without asthma. Okay, well, how can we quantify this as well? What are the odds? How much does having asthma increase the odds of you consuming sugary drinks? Well, let's see. Well, according to the odds ratio, you're 30%, 1.308, almost 31% more likely to consume sugary drinks if you're an asthma sufferer. Okay, how about our risk ratio, our relative risk? Well, our relative risk is in this next row, and the relative risk says you're 23% higher risk for consuming sugary drinks if you have asthma. You know, if you had reversed it the other way, you would have found the same results for sugary drinks, because it's you would have to think about whether you wanted to, whether you thought there was a cause and effect here, or whether it was just an association. But you'd have to decide which to put in the rows and which to put in the columns. Okay, so now can I reject the null hypothesis here? Well, when I use chi-square, my null and alternative hypothesis are that there is no association between these two variables, and alternatively, there is an association. So we can reject the null hypothesis, there's no association, and accept the alternative that there is an association. Now, as far as odds ratio is concerned, for instance, I can see here that it suggests that there's 31%. Your odds are 31% higher that you consume a lot of sugary drinks if you're an asthma sufferer. However, I need to set up a null hypothesis here also. Well, the null hypothesis here is that if there were no association, if it didn't matter whether you had asthma, then both groups would be drinking sugary drinks at the same rate. So the odds ratio would be the odds of for people that have asthma and people that don't have asthma would be the same. So the top and the bottom of the odds ratio would be the same. So that would be equal to 1. So the odds ratio, when there's no association, is equal to 1. So our null hypothesis is the odds ratio is equal to 1. Now, alternative hypothesis is that the odds ratio is not equal to 1, that there is a greater frequency or rate at which, or risk for people who have asthma to be drinking sugary drinks. Okay, so that would be expressed as odds ratio does not equal 1. So in this case, in both cases, we can reject the null hypothesis because we can see our 95% confidence interval does not include the number 1. So that means that we're 95% sure that this is really different than 1. So we can reject the null hypothesis that the odds ratio is equal to 1 and accept the alternative hypothesis that it's not equal to 1. So both allow us to reject our null hypothesis and demonstrate an association here. Okay, so that's how this worked out pretty well for two variables that with a 2 by 2 table that we created. Well, now how about if we looked at a couple of these other variables that we have? So, for instance, let's take a look at whether or not people that drink sugary drinks have a higher body mass index or not. Well, how would I do that? What kind of variable again was sugary drinks? That particular variable was yes or no, right? I drink sugary drinks. or don't drink sugary drinks. Okay, so I have a variable, a categorical variable with two values, right? And I have a numerical variable called body mass index, okay, BMI or body mass index. Well, how would I compare that? How would I compare people who drink sugary drinks versus people who don't drink sugary drinks, and to see whether the mean body mass for either for those two groups is different or the same? Well, that's a t-test, right? We've done that many times. That's a t-test. Let's give it a try. Analyze, compare means, independent samples t-tests. Okay, and the test variable is a numerical variable, which is the body mass index, and the grouping variable is the exposure, which consumes one or more sugary drinks, and it's going to ask me to define the groups, and what it's asking me for is the numbers that are represented. So 1 and 2 numbers are represented. In other words, drink sugary drinks, doesn't drink sugary drinks, as we noticed before. So now I'm going to click OK, and it's going to perform a t-test for me. And sure enough, here is our t-test, right? And it tells me that the mean body mass index for people who drink sugary drinks is 27.6, and the mean body mass index for people who don't drink sugary drinks is 26.8. Well, it looks like people drink sugary drinks have a higher body mass index. Is this statistically significant? Again, what's our null hypothesis? Our null hypothesis is that the mean body mass index for people who drink sugary drinks, mu for people who drink sugary drinks, is equal to mu for people who don't drink sugary drinks. Our alternative hypothesis is that those two means are not equal. Well, I can see there's a difference in the mean here. Is it big enough to say that difference is statistically significant? Well, in fact, if I look at the t-test here, the t-test is very large. I'm not going to bother to worry about equal variance is assumed or not, but it looks like standard deviation is very close, so we could assume the top line equal variance is assumed. It looks like the t-score is very large, and in fact, the significance, the p-value, is less than 0.05, so we can reject our null hypothesis that there is no difference between. We can reject the null hypothesis that there's no difference in the means of the body mass index means for people who drink sugary drinks and people who don't drink sugary drinks. So there, we've done any one of these two analyses could have been something that could have been the basis for what you're doing in your project. So now I'm going to do another interesting one. Again, just with these particular variables that I picked out. One of the things I've included here was the boroughs, right? Body mass and borough of residency. Now I know there's going to be 5 values. I should go in here and code it. Number 1 is Brooklyn. Number 2 is, well, why not? Let's do it, right? If we're going to do this, might as well do it right. Okay, let's see what did I say? I don't think I saved borough. I'm going to have to open that code book again. Let's see, review, desktop, review project. Okay, here we go. Code book. Okay, now let's go to borough of residence. One is, hey, let me grab it and get this out of the way. Okay. I'm going to save this borough. Okay, so let's go back here. And let's go back in here. Borough of residence. Go ahead. Let's go ahead and code this. 1 was the Bronx. Okay, let me get it opened again. Two was Brooklyn. 3 was Manhattan. 4 was Queens. 5 was Staten Island. Okay, so I'm going to say okay to that. So we've coded that variable now. So now I want to know, for instance, whether there's a difference in the body mass index for people that live that have residence in the different boroughs. In other words, where are the skinny people? Where are the fat people? Are they in Brooklyn? Are they in Queens? Are they wherever? Okay, so let's give this a try. Okay, so what test would we use now? Now we're comparing means, body mass index, right? So we know that's a numerical variable. We're comparing means, but now instead of 2 groups where we use the t-test, like as we just did, now I have 5 groups. What test do I use to compare the means of 5 different groups to see if they're the same or different? Do I got an opinion there? ANOVA, perfect. Thank you. I'm so glad you showed up today, Nadira. Okay, so let's take a look at that. Analyze the script, actually compare means, one-way analysis of variance. So I'm going to move into my dependence list of numerical variable, which is body mass index, and into my factor list. What I'm going to break that up into, different means I'm going to break that up into, is my borough of residence, which we just coded. Okay, so now our null hypothesis is going to be that there's no difference between the means of the residents of each borough, mean body mass of the residents of each borough. Mu Brooklyn equals mu Bronx equals mu Queen equals mu BMI for Manhattan equals mu BMI for whatever borough I've left out as I was talking. Okay, so I'm going to go ahead and do this analysis. Click OK. And here's our analysis of variance. So our null hypothesis is that no difference between the means. Our alternative hypothesis is there is a difference between the means. Well, let's take a look. Our F value, our analysis of variance statistics, comes out to be 36. That's a big number for such a small grouping, right? And our significance, our probability of being wrong if we reject the null hypothesis, is less than 0.05. So this is 0.000. So we reject the null hypothesis. There is a difference between the means of the different boroughs. Well, now the only problem I have now is it all of the boroughs are different or only some of the boroughs different? So for that reason, we go back, we run compare means, one-way analysis of variance. This time we pick out post hoc tests as well. So I'm going to do Bonferroni. That's a conservative test. I'm going to choose that particular type of post hoc test. I'm going to click OK. We'll run this again. And this time, let's see what we get. SPSS compares each one of the boroughs to all the other boroughs, Bronx to Brooklyn, Queens, Manhattan. And what I'm looking for here is I'm looking for significances that are less than 0.05. Excuse me, significances that are less than 0.05. And I can say then that reject the null hypothesis for those comparisons. So Brooklyn versus Bronx, that's significantly different. Bronx versus Manhattan, significantly different. Queens versus Bronx, significantly different. Bronx versus Staten Island, we have not proved them to be different means. Okay, that's not significantly different. Okay, how about Manhattan and Queens? We haven't proved a significant difference there. On the other hand, Brooklyn and Staten Island, we haven't proved a significant difference there. So in some cases, you've proved a significant difference. In other cases, you haven't. So you have all these different possibilities. Now, of course, it would help if we knew what the means were. Okay, and we could actually calculate that by just doing our descriptive statistics explorer and putting BMI in here, and in our factor list, putting borough of residence. So we actually calculate all of those values that we need. Okay, so we know what the means are. So here they are. So the mean BMI for Bronx was 28.2, for Brooklyn is 27, is Manhattan is 26, Queens is 26. No wonder we didn't find a significant difference between these two guys. Look how close they are. And Staten Island is 27. So obviously, going to be likely to be a difference between Queens and the Bronx because numerically, the mean BMI, average BMI for those boroughs is very different. Well, we also, in the process of doing this, wind up getting the box plots of processing. There's the box plots. And you can kind of, a lot of outliers, but you can kind of see that some of these are this one and this one, the Queens of Brooklyn, very close together, right, about the same level. But this is lower, this is higher, so it seems to be difference in Manhattan and Staten Island, which we turned out that we proved in our post hoc tests was significant. Generally, a lot of data here. Sometimes this might even be better to just pull out the information that we need, the parts of it that we needed, the means for each different borough, and maybe summarize the post hoc test to say which of them were significantly different, and ignore the ones maybe that weren't significantly different. Just something to simplify this a little bit rather than just, like copy and paste in a giant table. Although that wouldn't be terrible either. That wouldn't be wrong. It might be a little bit clearer if we summarized it a bit ourselves. Okay, so that's the way that we would analyze that kind of situation where we have a categorical variable with more than two values and a numerical variable. Okay, so I want to get to one more possibility, and that is if you're dealing with, actually, I think we're in pretty good shape there, right? Well, here, let's say, diabetes. Let's say we're interested in seeing if there's a difference, if there's an association between the borough you live in and whether or not you have asthma. Okay, so let's give that a try. Okay, so let's go to analyze. Now, what kind of variables are those? That's a categorical variable for asthma, and it's a categorical variable for borough. Now that, as we just saw, is going to be a chi-square test. It's going to be a crosstab and a chi-square test. The only problem is that we're not going to be able to do odds ratios because they're not 2x2 tables. It's not going to turn out to be a 2x2 tables. Let's do it anyway, see what we get. Analyze, descriptive statistics crosstabs. Okay, and I'm going to take these out of here. Then I'm going to go in here and I'm going to say in the rows, I'm going to put the borough of residence. That's our exposure. And in the columns, I'm going to put, yes, Hazard doesn't have asthma. So I'm going to go into cells and I'm going to leave a percentage by rows. I'll leave that alone. In statistics, I'm not going to check off risk because it's not going to, as a matter of fact, I'll leave it checked off and you'll see it won't do it anyway. And I'm going to click OK. So let's see what we wind up with. So what we wind up with is a 2x5 table, right? How many degrees of freedom in a 2x5 table? Let's see. 2 minus 1 is 1. 5 minus 1 is 4. There's 4 degrees of freedom. So let's see what we see here. So let's see. Bronx, 17% of the people, 17.7% of the people in the Bronx that we surveyed reported having asthma. Well, how about Brooklyn? Wow, look at this difference. Only 11% of the people in Brooklyn reported having asthma. 14% in Manhattan. 8.9% in Queens. Look at this, only and 9.9% in Staten Island. Interesting. Look how much lower the rate of asthma is in our survey in Queens versus the Bronx, right? And then, isn't that pretty interesting? Now, is this a significant result? Let's do a chi-square test. And here is our chi-square test. And our chi-square test indicates that the probability that we would be wrong if we rejected the null hypothesis that there was no association between borough of residence and whether or not you have asthma, that there was no association, our chi-square test it has far less than 5% chance of being wrong if we reject the null hypothesis and say there is an association between what borough you live in and whether or not you have asthma. Okay, so the only thing is that we can't run a risk estimate or a odds ratio on this because we need a 2 by 2 table to do that. There is a way around that where we, for instance, we could, compare just the Bronx to let's say the lowest one here. Let's say the Bronx to Queens, right? Just look at those two variables, those two values for residents rather than all five at the same time. Just compare Bronx and Queens and get an odds ratio for the comparison between the two. How might you do that? Well, it's a couple of ways you could do that. One way is to create a new variable. So here is the boroughs, right? Oops, what did I just do there? Let me get rid of this. Well, I just accidentally clicked down there. Okay, so let's see. Here's the boroughs of here are the 5 boroughs of residence. The variable that indicate 5 boroughs of residence. I'm going to create a new variable. I'm going to go up here to transform, recode into different variable. And what I'm going to do is I'm going to take the borough of residence and I'm going to recode that into a new variable that I'm going to call Brooklyn, Bronx, and Queens. Bronx, Queens. And the label is Brooklyn, Bronx, and Queens. Okay, now I'm going to click here to old and new values. And I remember, I wish I remembered actually, to tell you the truth, I don't really remember. Oh, it's right here. Okay, I remember that let me move this down a little. I remember that 1 represents the Bronx. So I'm going to say in the old variable, I'm going to say that 1 is going to represent 1 in the new variable. And I'm going to click continue, add. I'm going to click add. Then I'm going to say, well, I don't want any of these others. I'm only interested in Queens, 4. Then I'm going to say, okay, 4 in the old variable is going to represent, I could just add, since I only have 2 variables, let's make 4. Let's make Queens in the old variable 4 represent 2 in the new variable. I'm going to click add. And I'm going to say continue. Okay, so now what have I just done? I have told it to create a new variable from the old one, where the only thing we're interested in is 1 and 4 in the old variable, and we want to move it over and call it 1 and 2 in the new variable. So I'm going to click continue, and I'm going to say, go ahead and make the change, and now okay. So now what happens is you're going to see that there is a new variable that's been created, right? That new variable is called Bronx Queens, and its label is Bronx and Queens, but it doesn't have the values coded. So I know that I told it 1 now is going to be Bronx, and 2 is going to be Queens. So now we have a whole new variable that only contains the values, the people that said that they lived in the Bronx and in Queens. And if you want to, we can actually take a look at that in the data view. Okay, and you can see only Bronx and Queens is represented here. All the other boroughs were excluded. That was the only part that was copied over. So now we can go into Analyze, Descriptive Statistics crosstabs, right? This time I'm not going to use borough of residence. I'm going to use our new variable, Bronx and Queens, in the rows. And I'm going to click OK. I'm going to click OK. Let's see what happens now. Well, this time it gives me a 2 by 2 table, right? Look, same number, 17.7, 8.9. It's just we've narrowed this down to those 2 values in this new variable. And my chi-square, my null hypothesis is that there's no association between whether the Bronx and Queens and whether or not you have asthma. Or my alternative, there is an association. Our chi-square comes out to very high, so there's a small p-value, 0.000, so we can reject our null hypothesis. Well, how about a risk or an odds ratio? Well, look, it looks like it's going to be about 2 to 1 or something like that, right? And indeed, the odds ratio is 2.215, right? And 1 is excluded from the 95% confidence interval for the odds ratio, so we can reject the null hypothesis that the odds ratio is equal to 1, or that there's no difference for the 2 boroughs. In fact, this also tells us that the risk is twice as great. Here's the relative risk The risk, which is 17.7 divided by 8.9, the risk, you're twice as likely to have asthma if you live in the Bronx versus if you live in Queens. Or phrased another way, which is more commonly used, the odds of your having asthma in the Bronx are 2.21 times as great as they are for people living in Queens. Okay, so we just saw a lot of ways we can use this data. Now I'm going to put the data set that I just worked on here on Blackboard. I'm hoping that you'll consider using your own rather than just this particular one. But I'm going to put it so it's available to you also. But you also have another version of this. You could go through the process I went through, where I selected through that big code book the few variables that we want and get rid of the other stuff. Or remember, we also gave you a code book that was a data set that was reduced for you from the major data set, okay, which we called CHS 2013 reduced set. Let me go back to it now. So desktop, and I have it in this folder here. Here it is right here. Here's the full data set, what we started with tonight. Right, excuse me, full data set, which is what we started with tonight. Here's the reduced data set that we created ourselves. And also, here is the simplified flu data set that was provided for you. I'm going to open that one up right now so we can end up with that. Analyze, up, data, open, data. And here's our simplified flu data set. I'm going to open that. Okay. And here are our variables. Demographic, we know that's age. Borough, we know that's the borough the person lives in. Race, neighborhood poverty group, insured or not insured, a different kind of insured. Flu vaccine, yes or no. Gender, U.S. born, nativity, or U.S. born or not U.S. born. Number of children under 18 and living in a household. Okay. In the variable view, you can see here's the variables that you have. It's been reduced to 10 variables. Some categorical variables, one which is a scalar variable that happens to be age, as it turns out. Right? So now you could use this data set. You could use the reduced data set that I just created with you, or you could use the full data set and pick out the 2 or 3 variables that you need. So I did I think about 4 different analyses that would be appropriate. Any one of them would be appropriate for something that you could do for your project. And by the way, one last thing, now the only thing is that the one we provided for you, Demog, is not coded. Well, age you're not going to code because that's numerical, so we would leave that alone. But borough, you would need to indicate to this data set that borough, 1 is the Bronx, 2 is whatever, 3 is whatever, just as we did before. 3, new race, whatever that represents, race or ethnicity of the variable or person interviewed. You would have to look up what the different numbers represent, and then the values indicated to SPSS. Insured or uninsured, insured or uninsured, let's see. Insured or uninsured. Okay, that's probably a yes or a no, and you would have to look that up in the code book and look up whether insured meant whether 1 meant insured and 2 meant uninsured or vice versa. Okay, and insured 5, that's the type of health insurance, and that might have several categories: private health insurance, Medicare, Medicaid, et cetera, et cetera. So you'd have to indicate which ones they were. Now, you don't have to code them all. You only have to code the combination that you're going to be working with. But I'll leave that for you to code yourself. If I see people getting a little desperate in a couple of days, then maybe I'll post a version of it that's coded as well, so you don't have to struggle with it. Okay? One last thing as I started to say, I think I said one last thing about 4 times so far. One last thing, and that is that I also posted from a Bio 610 class, a student that submitted early that told me I could use this with our other class as well. This is a version of her version of the project. I think it's very well structured. Okay, an introduction. She has an introduction that explains why she chose this, why she chose these variables, what she was trying to show. What she gave us a little bit of a background on it. She gave us a couple of uh, 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 references as well for where she got her information from. And she tells us what she suspects and what she thinks she's going to be able to show. Okay, and she proposes a alternative, null and alternative hypothesis. Okay, she talks about what methods were used in this study and what you could actually in this area. You might also put in the analytical methods that you're using as well. Okay, and let's see. Then she gave us some descriptive statistics, some information about how this population was distributed. Remember our age variable? Well, this is a histogram that gives us an idea of what our population looks like in terms of age. And this is what our population looks like in terms of nativity, people, the percentage of people born in the U.S. versus born outside the U.S. Pretty interesting, right? Uh, that alone is pretty interesting. The gender of the people that was surveyed, I think they surveyed more females than males. My guess is that those are combinations of reasons for that. This is unadjusted data, so it may just be that they got to more females than males when they did the survey. Okay, then she did her statistics. Since her particular examination, which examined uninsured versus insured, and whether or not a person was likely to have a vaccine or not have a flu vaccination. Well, she was able to use, since it's 2 by 2 table, she was able to use chi-square, and she was able to use odds ratio and relative risk to demonstrate that she could reject our null hypothesis. And these are the tables that she copied in here. And then she discussed her results in a bit more detail. She gave us her chi-square value, the p-value, and she explained this, what test she used, and what her justification was. And then finally, she gave us a succinct discussion of her results and her conclusions, and what her thoughts were about what the significance was of what she found clinically. Okay, so this is concise, and it covers all the bases that we're interested in our description and what we want in the report as well. Okay, it's very pretty also. You don't have to make it as pretty as this, but it always is pretty nice. So those of you that are strictly online, you have more time now to submit this. You have until the 18th. I encourage you to post versions of it on Blackboard for review by students, by other students, so you can get some feedback before you submit your final version in the assignment section for the project, or in the project section. Or occasionally you might get some feedback from me. I don't know that with so many students, I don't know that I'll be able to get to that many of you, but when I can, I'll be looking in there. But the discussion area is a great way for you guys to peer review each other's work and make suggestions and help each other out. Nothing wrong with, you got to do your own work on your own survey, but there's nothing wrong with collaborating with others to maybe have another pair of eyes that can help you out and make sure that you go in the right direction with this stuff. Okay, so that's posted now in both. In the online group, many people have posted their work as well. In brick and mortar group, have been a little more reticent about this. Right? We actually will see actual verbal presentations along with the paper project this coming Monday. I'm really looking forward to that. And remember, your presentation only going to last about maybe 4 or 5 minutes or something like that, because we have to get through all the students within the amount of time that we have that are going to do that. Shortly, I'll have the exam option for those of you that are really shy about this, the exam option posted. But I really suggest you do the project. I think it's a better learning exercise, and I think it's more likely that you get a good grade than it's more likely that you won't stumble on the project seriously. Where with the exam, you get you have unlimited amount of time to work on it until it's due, but you won't have any feedback. You only have one shot submitting it, so it's a lot easier to stumble on an exam than it is on this because you'll be getting some feedback from us as well. Okay, so and even when you do your presentation, if you get some feedback then that suggests you change something, you'll be able to make that change and upload it after class because the actual the paper presentation isn't due until the end of the day on Monday. Not and you'll have already done your presentation by then.